Hello, I'd like to welcome you to the webinar on microbial food safety issues in organic foods by Francisco Diaz-Gonzalez of the University of Minnesota. My name is Alice Formiga and I'm the webinar coordinator for eOrganic. eOrganic is the organic agriculture community of practice with eExtension. We're a community of cooperative extension service personnel, researchers, ag professionals, organic certifiers, and practitioners. You can find all of our published articles, videos, and recorded webinars on our website at extension.org/organic_production. A PDF handout of today's webinar slides is available at the second link on your screen at extension.org/pages/61477. We're very pleased to welcome Francisco Diaz-Gonzalez today. Dr. Diaz-Gonzalez is a food microbiologist and professor at the Department of Food Science and Nutrition at the University of Minnesota. He conducts research on the control of foodborne pathogens and teaches courses on food safety and microbiology. He has been investigating the safety of organic foods for more than 10 years. Okay, well now I'm going to hand things over to you, Francisco. There'll be a slight delay and then you'll have control of the screen.
All right, good morning everyone. Can you hear me well, first of all?
Yep, we hear you.
Okay, perfect. Excellent. Thank you very much, Alice, for the invitation to present in this seminar series. I am very pleased to be able to address your webinar audience on a topic that has been of my interest, as you said it well, for more than 10 years, the microbial safety of organic foods. So. All right, so yeah, we're going to be spending some time discussing a number of issues related to food safety. As Ali said, I'm a food microbiologist. And the first slide I want to just get started is in this definition from the USDA organic rule for organic foods. I highlighted in red some of the topics specifically we're going to be covering related to the lack of fertilizers for organic foods, the need for pesticides. But the pesticides I want to specifically address that I'm referring mostly to the definition of that's given very often pesticides to sanitizers. And then the other item that I have highlighted here is the fact that composted manure is used as fertilizer and oftentimes raw manure. So the next slide, I'm sure many of you are very familiar with. Oops. All right, so the next slide is, this is a graph that probably all of you are very familiar, just to get you situated with the topic. As you know, the organic food market continues to grow, and even this was an estimate back in 2008. And as you probably are very familiar with, the latest numbers from the Organic Trade Association is actually the expectations for the 25 million hitting in 2010 actually were surpassed with 26.7 million. But as we speak, it's about 3% of the total food sales. What we have in this country are estimated to be now organic foods. So the consumer continues to demand organic foods for many reasons. Many of them, I guess, there are many surveys that that you've seen in which one of the main reasons why they're looking for organic foods, as you know, pesticides, the low level of pesticides. People are looking for more natural food, fresher foods, and many other attributes that people actually relate to organic foods. Many of them well-founded, some of them are still yet to be confirmed, but the reality is the perception for the consumer is very positive towards organic foods in general. Now, the particular topic I want to talk to you is on safety, and the safety issue with organic foods, I see this as a very polarized topic. From one side, we have those that are crying wolf whenever they hear about organic foods and the potential for foodborne disease, and they're automatically jumping that it's a major issue with organic foods. On the other side, the consumer assumes that organic foods are inherently safer than conventional ones, and this is where we've been dealing with, and scientists, we expect that we try to at least provide some level of rationale and middle ground for this polarized issue. So if we want to look at those issues on safety and organic foods, we could think about organic foods can have some positive aspects related to safety, in which you can think of organic foods will be more or have a higher level of safety. And the first one in the list, I'm not going to talk much about it, is the lower pesticide level. Probably that's one of the least contentious issues these days. I guess probably given the amount of data existing, most people agree that for the most part organic foods will have less pesticide levels and with less variety of different pesticides than conventional produced food. So the other issue is about organic foods or specifically organic meats, whether they're going to have less antibiotic-resistant bacteria. Earlier, or the first sets of studies that have been published seem to indicate that that's the trend, but that's something yet to be determined. On the other hand, the negative aspects that are perceived with organic foods could start from heavy metals, natural toxins, mycotoxins, which that's all I'm going to say in this webinar. And the main topic of recovery is the potential for pathogenic microorganisms, whether the organic foods will have or will not have greater risk for contamination with human pathogens. All right. So with microbial pathogens, you can look into three major categories that are reasons to be concerned, or that people have raised questions about organic foods. The first one is fresh fruits and vegetables, and the concern is that because the limited number of fertilizers are allowed by the organic rule, or organic practices in general, is the fact that animal manure may tend to be one of the most widely available and convenient inputs to be used for fertilization. In addition to that, and not only for organic foods, but the inherently weakness of fresh fruits and vegetables, which are typically not really processed, and they are intended to be eaten as they are. So they are not subjected to any kill step because they're meant to be eaten fresh or raw. The second aspect, and I'm not going to say any more about it, is the meats, the antibiotic, whether meats produced in their organic system that will have the benefit of having less use of antibiotics. And the third one, I'm going to mention a few at the end of this conversation, a few of our data that we've been looking on, and the issue about the lack of organic disinfectant sanitizers. It's one of the perceived weaknesses of organic production, because we don't really have a truly organic antimicrobial as we speak. There are many claims, and what I'm saying, truly effective organic antimicrobial. That's what we're still looking. All right. So in some ways, what I want to focus our attention is specifically the rest of this conversation on this question that it's in many people's minds is okay, so I'm the concern. What is the real risk of organic foods, whether they're going to be more susceptible for contamination, foodborne pathogens? So to answer this question, you can take different approaches. And obviously the first one of all, as always, whenever we want to answer a question whether a food could be more susceptible for contamination, we look at the epidemiological evidence. How many people get sick? How many people die from the particular food or particular practice? That's the first approach I'm going to discuss. The second approach that you could also use is, well, if you go out there and try to find a pathogen in food supply, are you going to find them? Are you going to find some indicators? We're going to look at two sets of data for this. And the third approach that you can take, whether to have this, try to answer this question, whether they're, what is the level of risk, is also assess some of the current practices. Specifically, we're going to be referring to the use of manure, and also the fact that of the limited number of approved sanitizers that exist according to the Organic Materials Research or Review Institute. Sorry. All right. Let's see. Okay. So the first approach is looking at epidemiological data. In some ways, I want to acknowledge the fact that this country has one of the best surveillance systems in the world. And an example of this is the new tool that the CDC has put out for the last 2-3 years. on which you can actually search into this website and you could find any outbreak that has been recorded in the last, well, it's this tool, the Foodborne Outbreak Online Database, has been out for, at least it records from 1998 for 2009. But the CDC has actually records all the way to 1990. But just from 1998 to 2009, if you just go into this table and search all of the outbreaks possible during this period, you'll find more than 14,000 outbreaks so far. And unfortunately, if you dig into this website, you have to do a little bit of tweaking with your search results, and then you realize that there is no single reference actually to an organic product, which it may or may not be intended, or may actually they have. What I'm saying is may have been purposely left out by the investigators. And the amount of data is kind of sketchy when you look at the food vehicle that the tool provides. So that's not, it helps somewhat, but it doesn't really answer the question, okay, how many organic foods have been linked to outbreaks? And for that, you have to dig a little bit more into the literature. And in this case, I've shown you just some examples of a data that sets of data from the literature on outbreaks of E. coli linked to manure. Those were not necessarily organic, but those were cases in which manure was conclusively associated with causing outbreaks of E. coli 157. There could have been more outbreaks with other pathogens, but I'm just referring to the ones on E. coli 157. So you can see in different this data from different states, countries, and I think it's the message is I guess this illustrates that manure definitely could be a vehicle for contamination of a pathogen like E. coli 157. Now, so you can start digging a little more in the literature, and a few instances you have publications that they hint that either they could have been caused by a product that was probably organic, but it wasn't completely confirmed. So only, I think the case of Germany, I think it was indeed an organic farm that caused it. The question is always whether it was certified, non-certified, and other questions. Now, if this is just three cases back in the 90s, and more recently, the first highly publicized case in which organic practices were implicated was the outbreak of E. coli 157 in 2006 with spinach. As you know, it was an outbreak that was a high-profile outbreak that has had a major impact on the perception of fresh produce safety. And this probably was one of the best investigated cases from which we learned a lot, and I think a lot of researchers and the industry has been benefited. I want to say with a kind of quotation mark, because in some ways this outbreak taught us a lot about where are the sources and how the potential points for control. So this outbreak basically shows that E. coli 157 was found in different spots in the production system, all the way to the neighboring cattle farm, the wildlife, the pigs, and the pigs were considered to be by many experts as the vector of spreading the pathogenic E. coli from the neighboring cattle farm all the way to the spinach field. It was detected environmental samples. This outbreak was also a major breakthrough because there were so many samples in which E. coli was detected. Excuse me. In samples taken from the patient's products, so it taught us really plenty of it. But it muddled a little bit the waters when it came down. Whether, if you remember what was going on during that period of time, there was a lot of finger pointing between one type of produce vegetable practice to the other. And the fact that this particular farm, Mission Organics, was in the middle of its transitioning time to become certified organic, but it wasn't really organic. So that opens up opened the door to blaming the potential problem to organic practices. But as you know, given the contamination or the investigation that was discovered, I think it's questionable whether necessarily that could be blamed on organic practices. So that's a big question mark after the outbreak. This year, I guess we probably, as far as I could gather, of course I may be wrong and maybe missing some of the previous outbreaks that I wasn't able to find, but this year in 2011, the first confirmed outbreak with organic eggs was actually reported. That was happened here in Minnesota with 6 cases. And before that, actually, we had the large outbreak in Germany with the emerging E. coli 0104H4, which is a very unique pathogenic E. coli. It's a massive outbreak that we haven't seen before, with 4,000 infections, more than 50 deaths, involved mostly Germany, but the infections occur in many other countries in Europe, and actually some of them occur here in the U.S. and Canada. And what the investigation show is that at the end of the day, we're supposed to have been caused. The outbreak was caused by fenugreek sprouts that were produced in an organic production facility in Germany, but the seeds were, as far as the investigation showed, that the seeds came all the way from Egypt. And you have to ask yourself whether this is it's indeed the seeds. We don't really know whether those seeds have been produced organically and under what kind of practices. Of course, this outbreak was so massive that immediately you could see all sorts of people jumping, and actually, I don't know if you remember anyone seeing the Washington Times editorial with actually demanding organic food moratorium as a result of this outbreak. So anyway, I guess unfortunately, I guess we don't have a lot of answers from the epidemiological side. We see that there may be some outbreaks occurring, but I think we can always have to ask ourselves whether, well, it's only 3% of the total food supply. Is this going to change once once organic foods become a larger share of the total food supply, so we don't really have a good answer from the epidemiological whether, or maybe the answer is there is no risk because we're not seeing a lot of them. But I think the lack of evidence not necessarily indicates that there's necessarily no problem. So anyway, the second approach that I want to discuss here to try to answer that question that I posed on the level of risk is what happens if we look for the pathogens in the food. So there are 2 possibilities. One, look at the data of recalls. Fortunately, we are having we have access now to really good, at least much better data than we used to have. And also we look at what is published in the literature. So for the recalls, the USDA and FDA have done a pretty good job on actually creating some search engines and actually a catalog of all the recalls that have been happening in the last few years. There's a couple of tools that are available out there on the web. One is obviously for FDA-regulated foods. The other one is for meats, poultry, and eggs for USDA. But this can give you a pretty good idea of what's happening in recalls due to any reason, pathogens, allergens, or any other reasons why foods are recalled. But you can dig into this couple of search engines, and you can find a lot of information in those regards. So I did a little bit of the same thing with the other search engine, but this time with recalls. And what I could find just for 2011, I found a total of 349 recalls, both combined FDA and USDA, from food so far this year till the end of November. And from those 349, approximately 150 were outbreaks that were due to the detection of pathogens. Some of these recalls could have been due to the microbiological detection alone, or some of them could have been due to the fact that the food was conclusively linked to an outbreak. So this is a mixture of different ones. And if you, in this database, you could actually find product that was listed as organic. I found a total of 6. 2 of them were due to presence of allergens, and there are 4 minor recalls were due to pathogens. We found an outbreak, a recall due to grape tomatoes, salmonella in grape tomatoes. The number 2 listed here is the same as the outbreak I just referred to earlier. Number 3, herbal tea that was found to be contaminated with salmonella. And the last one, baby spinach with listeria. So if you calculate this percentage of number of recalls, of 4 recalls out of 150, you have a 2.7%. Is that just the same share as the conventional foods? You could say that. But I think that's, again, this is relatively sketchy data that whatever it's available officially. All right. So the other approach that we take is, well, what is in the literature of surveys, extensive surveys people have been doing and sampling produce. In this case, the first couple of tables I'm showing you here is the presence of pathogenic organisms in fresh produce. And one of the consistencies all over most of the surveys, I want to point out to the column in the middle with the white numbers, it's finding pathogens with exception of the very first study that they found 35 salmonella positive pathogen samples among 1,000 imported foods. Most of the other studies have relatively low incidence of pathogenic contamination. And one of the things that you could also see from this table and the following table is that the E. coli 157 is a pathogen that is rarely detected in any kind of samples. And some of the studies included specifically organic foods. And we have listed one of our studies that conducted back in the early 2000s, in which we only found 2 salmonella, but basically in a total of 2,600 is the other part of the study. We didn't find any 157. And this is a trend that has been consistent in the recent publications, even the latest study from Canada that I didn't include here, but this local produce at the end in 2009 published. They also included, I think, a fraction of I don't remember the number, but several of the 673 samples were actually organic produce. So the data from product contamination seem to indicate that there's a lot of either conventional or organic. There's let's say a very heavy contamination of pathogenic organisms. So just briefly, you could also there are a number of researchers looking at the same question in poultry, and this I'm going to talk about meats. There is there appear some studies that show that whenever you have organic, there are a number of studies that found that organic have higher prevalence of some pathogens. Some studies from Denmark, from Ohio, they found higher prevalence of pathogenic organisms in organic poultry, but there are some of them that didn't find any differences. So it's mixed series of results here. All right, so let's go back to our list of approaches. So the last one is how to assess the current practices. The use of manure, that's one of the ones I am being particularly interested. And then we're going to look at the limited number of approved sanitizers. With manure, these are the list of currently approved practices when farmers can use manure. And the main recommendation is manure should be used composted. That's the main recommendation. The composted, you can have the 2 temperatures depending whether it's in vessel or the range of temperatures, and the 2 length of time depending whether it's in a reactor, if it is in a pile, up to 15 days. And according to the organic rule, if it is not composted, it allows the use of raw manure if it is applied at least 90 days before harvesting, or at least 120 days before harvesting if the produce is in direct contact with the soil. Now, one of the things that you have to understand with this recommendations that were issued more than, I don't know, close to, or they came up with them more than 12 years ago. And by the time when the organic rule was issued, there was very limited data. And this is just some information that I got some years ago from Eric Sitterman, who was sitting on the National Organic the regulatory bodies are for a moment like the National Organic Program. So it was mostly based on E. coli 15787, and the group that came up with this recommendation was actually acknowledged the fact that they didn't have a lot of data back then. So this is the set of list of publications that they use for each of those recommendations, specifically on the use of raw manure. And in the case of composting, we know that if the compost is done properly, either in reactors, and temperature reaches, especially above 55 degrees and closer to 77, the pathogens such as Salmonella and E. coli and Campylobacter will not survive. And if you're done in piles, definitely one of the issues that doing in piles is making sure that turning the materials to making sure that it's the temperature exposure is done evenly. And with composting, that's and the concern has been, and a number of other people that have done more research in this area have brought up the issue of uneven temperature distribution, the potential for cross-contamination that happens, maybe happening in some composting operation, and also there's a wide range of composting systems that some of them may or may not ensure complete reduction of pathogens. But if it, in a nutshell, if composting is done properly, we should be controlling pathogens, at least human pathogens. Okay, so looking at pathogen survival in raw manure or in soil, these are the two length of time, so 90 and 120 days. And as I said, initially, there's been plenty of research going on in the last 10 years in which researchers have investigated how long those pathogenic organisms actually are able to survive in manure and soil. And this is just shows us a few of the relevant work that you could see in the column of the middle. I think these are the first table is pathogen survival in manure. And in here you can see in the middle the column that people have found different times and maximum survival that the organism was able to be detected. 90 days, 260, 100, 100, and then we have 200 days down here. And when the manure is mixed with soil, then you have a set of different data depending on the, and then the conditions get a little more complicated because you have different manure type, different soil type, different pathogens, but still, I guess the numbers that are coming up are in some way all over the place. I guess you could have some studies like this study by Hutchinson in which the survival was relatively short, and most pathogens were not detected beyond 3 months or so. But at the same time, we have studies like this one from Islam in which you have survival depending on the type of vegetable as long as 214 days. And of course, this one in the bottom with survival of E. coli 157 in frozen soil for 500 days. Of course, that might be very unreasonable unless you're reading the articles on other places. Anyway, so the second table was pretty much the same situation. Some of them are short, some of them much longer, and depending again on the conditions, the pathogens, etc. So it's what the take-home message from looking at this set of data of survival of pathogens is that there is a possibility that pathogens can survive beyond the 120 days recommended by the organic rule, but in some cases they may not survive, so it's very uncertain. All right, so the last part that I want to discuss in this webinar is the assessing the current practices given the fact that we don't have a lot of antimicrobial to use in organic food production. So just to remind you a little bit what I'm talking about. When you process foods, typically food processing plants, they have to conduct sanitation. And typically sanitation is recommended is done in 2 steps, the cleaning, where you remove the coarser material from surfaces. And then a second step in which you you kill whatever is remainder in the surfaces of the equipment or the facility. And typically, the second step, the sanitizing methods, is typically done either, could be done physically. You can use heat, hot water, and steam to kill pathogens remaining on equipment. Surfaces, you could also use irradiation, such as UV light. But the approach that a lot of the food processors have been using is using chemical sanitizing because it's very effective. The way the chemical sanitizer is defined legally is referred as non-rinse food contact surface sanitizer, and according to the EPA official method, it has to reduce E. coli and Staphylococcus aureus by 5 logs in 30 seconds at 25 degrees C. That's what qualifies any substance to be considered a surface sanitizer. Now, obviously, there is also the consideration for any toxicity too. So the currently approved non-rinse food contact surface sanitizer by FDA, this is not an extensive list, but those are some of the most important chemical compounds. This is not approved for organic. This is what's approved for any conventional food production. So it involves many different active ingredients. And when it comes down to organic foods, in organic foods, as you know, when the organic rules were issued, regulators were faced with the fact that it was going to be really difficult to have every single food to be 100% organic. So there was some exception of allowing some synthetic ingredients to be used for organic production. So that way we will be able to still produce some food and still consider under the category of the 95% organic. And then we could still use the label of USDA organic. So then they created a national list for allowed and prohibited substances, which lists all the different ingredients that could be allowed for organic production. And they divided them mainly into 3 major categories for livestock, crop production, and processing. All right, I'm not going to go through this list, but the National Organic List has a specific set of criteria in order to approve a substance going into this national list of approved and allowed substances. And for sanitizers of antimicrobials in the National Organic List, we have as many as, right now, we have as many as 7 different categories right now. We could have alcohols, ethanol, isopropanol, and I'm going to put it in this grid is basically in green where, as far as I could gather from the Organic Material Review Institute, which ones were actually approved for use in each of the 3 categories. We have chlorine compounds, and they could be used for, in the case of sanitizing equipment for processing, as long as the final residual chlorine concentration doesn't exceed 4 milligrams per liter. Hydrogen peroxide is also approved. One that was approved, I think, approximately 3 years ago for acidic and peroxycidic acid, which is it's a sanitizer. It's very effective. And then we also have hydrophores, and some of the ones the newest in this list are citrus products and the lignin. I'm not sure about the regulatory status for livestock and crops, but I know it's listed to be used for process equipment. So those are listed as organic or approved for organic use. Now, in looking for alternative sanitizers and antimicrobial ingredients that it could have potential to be actually non-synthetic, we could try and find natural salts, natural plant nectar. This is an area of research that is very active these days. There's an extensive number of groups that are actually looking at different natural compounds. And then we have the category of microorganisms that we could have antagonistic bacteria. You could have microbial viruses or bacteriophages that attack specific organisms. Let's now going to be, the remainder of this conversation will be focusing mostly on bacteriophages, which is one of the projects we've been working in our laboratory. Bacteriophages is not a new approach, has been investigated for more than a century, and actually in some countries of the former Soviet Union it used to be used extensively, and in some of them they're still used instead of antibiotics. And it presents a lot of advantages, that's why, and given the fact of the advent of emerging bacteria that are resistant to antibiotics, it's seen as a very promising alternative. So one of the benefits is because it's very specific. There are obligate parasites. You could find them relatively easy in nature. People argue that this is the most widely available arguable life form. It could be very cost effective. When we started this project, there used to be phage preparation was approved for organic production. And actually, the use of phages for use in foods was not long ago approved by the FDA back in 2006 and 2007. So for organic foods, as we speak, this is something I was a little surprised recently that I searched for Agriphage, which was the one I knew was approved or was listed in the Organic Material Review Institute. That was the first phage that was approved against Xanthomonas campestris on Pseudomonas species. But it's not listed, so I cannot find it. So I don't know if anybody could give me a better answer for what happened there. But anyway, right now, if you look at the list of the Organic Material Review Institute, there are a couple of listeria phages, and they're not listed on the Sanitizers or antimicrobial. They're just listed as microorganisms allowed for use in food production. And you have List XP100, which is marketed by a company called Micros Incorporated, originally developed in Europe. And there is another product, List Shield by Intralytics, which is a company here in the U.S. So the precedent is there that it could be used for organic production. So in our project, we've been working for almost 4 years in isolating, screening, and evaluating bacteriophages against 3 pathogenic organisms: E. coli, O157, and other Shiga toxin-producing E. coli, Salmonella, and Listeria monocytogenes. So this is a project. The first set of data is on the phages specific against E. coli, which is most of the work was conducted by a PhD student who finished his degree, and we pretty much published almost all of the papers on this topic. We only have a paper left to publish in this regard. And the first table shows just the screening part of some of the individual bacteriophages that we tested. And one of the interesting facts of this first table is the fact that this set of phages were extremely effective against E. coli 15787 strains. We've tested as many 130 strains. And it also attacked some other serobars. Now that the non-157 stack are really major interest. 026, but 0111 was not affected at all, and the effect on other commensal E. coli was also not as great as it was with 0157. Other E. coli were not affected, as well as Salmonella. So the good news for this set of phages was very specific against E. coli and 157. We use a combination of 8 of these phages to treat stainless steel surfaces against strains of 0157. And we investigated the effect of using increased levels of phage as you move from an MOI of 1 down to an MOI of 10. That basically indicates that the ratio of phage particles to bacterial cells increase. So the more phages we use, the better results we get. And also we investigated the effect of exposure time and the exposure temperature. You get really nice reductions at the time when we were in the high level of bacteriophages. The maximum was here close We use the same phage preparation to treat vegetables, and this shows the data for spinach and lettuce. Similar to treating inert surfaces, in the case of lettuce, we also had the same trend. At the highest concentration of phage, we had the greatest effect, and also at the effect increase with temperature. And also with time of exposure, we get the greatest effect. We have also been working on phages against salmonella. This shows the list of 5 of those phages and their effectiveness against a set of different salmonella serovars. With some of them, the first 2 set of the phages, SE1 and 2, a very extensive effect on many of them. And we have tested the range of serovar effect. Now, this is one of the limitations we found with this set of phages, that while some of them are effective against 3 serovars, rarely you find any phage that could affect a wide array of different serovars. The last set of data I'm going to show about our project is just the screening of phages that we've been conducting against Listeria monocytogenes strains, and this data just shows it's similar to the previous salmonella table, some of the effectiveness of 10 different Listeria phages against an array of different Listeria monocytogenes strains, with some of them showing very good effect against the different strains. So very good range of broad spectrum against monocytogenes. All right, so I'm pretty much almost at the end of the seminar. Just to summarize what I've just discussed, and I think I'm really looking forward to this discussion and having answer your questions. But basically, the epidemiology does that the data that I was able to find. You don't find it what they politicians often call is the smoking gun of that organic foods are really causing major problems. But always the big question mark is this because of still the small share of the total number of food produced in this country. Survey studies, at least in produce, didn't detect increased contamination of organic foods. The use of manure seems to be linked to outbreaks, and I think it's a concern that we cannot ignore. Manure is a vehicle is a source, a vehicle of pathogenic organisms. But at the same time, the studies in the list of studies that I showed kind of seems to indicate that we cannot really predict survival of pathogens in manure and in soil. So, but I think the data seems to indicate that because there is a possibility that they may survive beyond the current 90 and 180, 120 days recommended, that maybe you should think about revisiting those recommendation days. So the need for effective sanitizers is there. I think it will take a lot of ingenuity and creativity from researchers to come up with effective alternatives that could be used for organic production. And among phages, I guess it's a natural alternative that I think it's worthwhile to continue exploring, not only for organic but in general as an alternative to other type of antimicrobial strategies. All right, so I just want to acknowledge that the fact that the Bacteriophage work was funded by the Integrated Organic Program from the USDA. Now I know it's called differently. That we got support to work in this project, and most of the Bacteriophage work has been conducted by 2 individuals, Dr. Mastura Luna Akhtar and Dr. Stelios Biasis, who is now actually works for the FDA as part of the newly formed investigative group for outbreaks. And with this, I conclude my seminar. We'll be very, very interested to hear your questions or any suggestions or any of your input. So thank you very much, and I'm looking forward to your discussion.
Thank you very much, Francisco. We're about to start our question and answer period, so for anyone who missed the very beginning of the presentation, you can ask questions by using the question box on your screen to type in questions and hit return. I know we've started to get questions, and we have a large audience, so we may get quite a few questions, so we'll answer as many as we possibly have time for in about the next half an hour. This webinar is being recorded, and it will be posted to the link on your screen along with the slides as a PDF handout, which is already there. If after the webinar you have additional questions, you're very welcome to use the online Ask an Expert system at extension.org/ask, and you can also find our other upcoming and recorded webinars at the link on your screen. Finally, we really value your feedback on this webinar, so we'd very much appreciate it if you could fill out our follow-up survey, which will arrive in your email inbox later today. So now, without any further ado, let's move on to the questions. The first question we got goes back to the earliest part of your presentation, around slide 8 or so, where you were talking about the advantages of organic foods. And we have someone who wanted to know whether he understood you correctly to say that the veracity of less antibiotic-resistant bacteria is yet to be determined. Can you talk a little bit more about that?
Yeah, I think I wanted to be a little cautious on actually giving a really strong statement that is conclusively that organic production system conclusively lead to less antibiotic-resistant bacteria. The data seems to indicate there, but I just wanted to, my statement was along the lines that I wanted to be somewhat cautious. That given the data that's out there, it seems like that's what it's looking. I hope that I clarified that issue.
Okay, great. We had another question about something else that you talked about, which was the reference for the 5-log reduction criterion. Do you have a reference for that by any chance?
I didn't include it. You mean the EPA? Yeah, there is an official method from. I don't have it in top of, but I'll be happy to email it at this point. That's kind of the definition of anybody that wants to sell a new organic sanitizer. They need to deliver. It's an official method in which you have a culture of E. coli or Staph aureus, and the strains are standard strains. And you treated the culture with, I think you put 1 ml into 9 ml of the sanitizer, and it has to kill the culture in 30 seconds. But I don't have it on top of my head, and I got to remember where it's actual. But it's an official method. If you Google it, probably you will likely find it as sanitizer EPA method or something like that.
Okay, I can email you afterwards too, and we can maybe.
Yeah, I don't have it right now available, but I can find it quickly.
Okay, great. Let's see. This one is a 2-part question. It's a little complicated, so I hope I can understand it here. It refers to the 4 parts per million chlorine on equipment regulation. It says the National Organic Program guidance doesn't require a potable water rinse following the use of chlorine on equipment. Is it necessary to let the chlorine product drain and dry before the equipment contacts organic products?
My understanding was, and maybe I'm not very familiar with actual practice, and I was aware with regarding the use of chlorine. A lot of this was also left to the interpretation by the certifying agency, so I'm not 100% sure. My understanding was that the equipment should have been rinsed to a level of 4 ppm before it got in contact with the product, but I might be wrong in that one. I know that according to the guidelines, it says that the residual 4 ppm or milligrams per liter of chlorine, but I am not 100% sure about it. I know in many ways this has been left a lot to the interpretation of the certifying agencies or bodies. But yeah, sorry not to be able to give a very straight answer.
Okay. Let's see. The last part of that question was whether a chlorine product could ever be used in direct contact with a product as opposed to with water.
Good question. I think that's a matter of principle of what is organic and non-organic. I guess we, in organic, we try to minimize. So that's I've never been involved in the National Organic Program. So if there is anybody in the audience that is part of the program, probably would like to get some input from them.
Yeah, if somebody wants to weigh in on that, please feel free to type a comment into the question box. Let's see, here's another question. Could flame heating soil after using manure and prior to planting cut down on pathogens?
Flame heating, yeah, heat kills pathogens for sure, at least the kind of pathogen we're worrying, E. coli and Salmonella. But I wonder whether the flaming will be thorough enough to kill the bacteria, but at the same, what would be the implications for, like, let's say, we would consider the good bacteria in the soil. So I don't think that's, I haven't seen anyone try actually advocating the use of flaming to control pathogens in mind, but I don't know, that could be a possibility for investigating.
Okay, thanks. Let's see. Next question. Are you aware of research into the efficacy of hydrogen peroxide plus perioxyacetic acid, or Sanidate, in reducing microbial load in fresh produce wash water?
Yes, there are several publications that the use. Well, now hydrogen peroxide, or peroxyacetic acid, in reality is a mixture of hydrogen peroxide and peracetic acid. And there is plenty of, I think I've seen several publications in which they have tested peroxyacetic acid, which is basically the mixture of the two, on treating vegetables. So yeah, the question is yes, there is evidence for the effectiveness. Now, I don't remember the extent of reduction. I know that companies such as Ecolab, they've been selling a product like that, I think by the brand Tsunami. And of course, there's other companies, I don't remember the brand, they sell something like that. But yeah, it's been used in that regard.
Okay, we have 3 questions that are pretty similar, and they're all related to the practical purchase and application of these bacterial phages. How are they purchased, and how would they be applied to the produce?
How are they purchased? Good question. As a researcher, let's say I only approach one of those companies, and I think researchers, I'm not going to get those phages if I don't sign a material transfer agreement. But if you're a producer, I think those companies would be glad to work with you. And my understanding is, depending whether you want to apply it for foods or you want to apply it for environment control of the listeria, they have different approaches. From a source that I know of a meat company, one of the strategies is actually going to your plant, testing what strains of listeria you have in your plant, and then recommending the best mixture of phages for your case. That, in some ways, of course, that's a questionable practice. But I guess going back to your question, I would hope that if you're a producer and you have interest, I think they have some sort of marketing department, those companies, that they will be happy to work with you depending on your application. I think more than anything, the companies actually, they don't sell it by the pockets just like that. They work with you depending on what your needs, and they may come up with a mixture of phages, because some of them actually have mixture of phages. And I imagine they have data that they indicate, depending on your application, they will give you one or the other. But it's not something that you just go out there and buy in a catalog.
Okay. Yeah, I guess people are interested in how exactly they're used. Like, for example, is the produce washed and then dunked in the water bath that contains the phages, or is it applied as a spray? Or do you have any idea about how
Oh, I'm not sure if many people are actually using them. Not because they're approved necessarily means that the people are using it. But the way we have applied, for research, we applied very specifically on a specific spot of the lettuce leaf, let's say. But in the case of usage, I think and again, it depends on the application, but I would think in the case of what I've seen, unfortunately, I haven't seen or I haven't seen the recommendation, because the two listeria-phages, they're not really intended for vegetables. The ones that are out there approved in the market. There is one other phage that is not approved for organic right now, but is being given. The FDA gave they're okay to be used for carcass washes. That's for an E. coli phage. The same company that makes the agriphage, they had some time ago they had announced that they have given approval from FDA, and they were just using it for rinsing carcasses. For vegetables, I would say probably the best way, if you don't want to be making aerosolized phage, probably the best way to apply would be dipping the lettuce in phage suspensions.
Okay. Let's see. Here's a question. Would phages, like other antagonistic microbes, be naturally present in adequately made compost heaps? Would there be an alternative to liquid fermented preparations with manure and added trace elements? Those two different questions there.
So, okay, so the question is whether phages would be present in compost?
Yeah.
Yeah, well, phages are naturally present everywhere, I guess. And for example, if we're looking for phages against E. coli 157, the best place to find them is in cattle manure, because E. coli 157 is going to be present in cattle manure. So you would think that if the compost comes all the way from from cattle manure, you would find phages there. Now, my guess is that composting would inactivate the phage, the phages. So composted manure, if it was done properly, wouldn't have active phages, so you wouldn't have any activity. If you had raw manure, yeah, you would hope that they have some phages, but the issue is those phages were not specifically screened and selected to control E. coli, and maybe there are many things that we don't really understand about some of the zoonotic pathogens such as E. coli 157, and maybe some of the fluctuations we see in E. coli 157 in cattle may be due to changes due to phages. So, but that's completely out of our control. So we don't. They may be there. They sometimes may see that the reason why we don't find E. coli or other pathogens may be actually due to those natural phages. But the problem is that we are seeing problems of human cases of those organisms. So definitely, we cannot just leave it to nature to take its course as we speak, unless we find a way to stimulate that those phages that are naturally present may actually be able to control the pathogen organisms. Now, what was the other part of the question, sir? With metals?
Okay, I guess it was whether they would be an alternative to naturally fermented, to liquid fermented preparations with manure and added trace elements.
Okay. Yeah, that's. I guess that's exactly what I just said. I guess if we find a way to stimulate naturally that those phages would be more widely present, yeah, why not? But I think that's we still need a lot of. We don't understand a lot of things about microbial ecologies.
Okay. We had another question about what their survival time is in the field.
Of the phages, or?
Yeah.
I haven't seen data about it, actually. I think in your case, let me see if I remember whether we have done some studies, but only in foods. We haven't really gone all the way to apply it to fields. And the only phage that, at least for organic foods, was originally approved for the field was the agriphage, which again I'm puzzled that is not listed anymore. but I haven't seen data of how long they're going to last. Phages may tend to be somewhat sensitive to external conditions. Some of them are more resistant, so they may tend to die because they mutate as a result of the exposure to light. So the short answer is I'm not sure about how long they're going to last in the field.
Here's another question about phages. Would the insurgence of resistant strains to bacteriophages be a problem as bad as the antibiotic resistance we already observe?
Well, yeah, that's the lessons we learned with antibiotics is that whenever you use an antimicrobial intervention, either natural or artificial, bacteria will find their way to survive. And I think I guess this phage preparation, for example, the reason why we're using cocktails of phages is we're anticipating that there will be some natural resistance already existing from many strains against some phages. So by using mixtures of phages, we are anticipating the fact that maybe we're going to be able to address all the different resistance. But you're right, I guess. Eventually down the road, if phages ever become as widely used as antibiotics, we're going to be facing the same problem sooner or later, that eventually bacteria, we're going to be isolated, we're going to be selecting for the most resistant strains against the phages.
Okay. Here's a question from Washington State, well, I don't know if it's from Washington State Extension, but it mentions their research on showing the effective use of lactic acid for sanitizing poultry at slaughter prior to chilling and freezing. Yep. They found fewer microbials than chlorine and did not have to refresh the tank as often as chlorine materials. Have you found any information regarding the use of lactic acid as an effective sanitizer in organic production system?
Not in organic production system, but I do know organic washes are widely used for different meat products or carcasses. So yeah, lactic acid and that's something I don't remember whether. I think several years ago I had the idea that lactic acid was not accepted for organic. As an organic sanitizer, but that may be changed. I couldn't find it in my search recently. So, yeah, the short story: if lactic acid is allowed for organic practices, then it's could be an effective treatment for carcasses.
Okay. Here's a question. Some growers have the perception that organic soils are more alive, meaning that they have a more complex, thriving ecosystem of microbes than conventional soils. This belief leads them to believe that pathogenic microbes introduced to their fields via manure would not be able to survive and flourish as they would be outcompeted by the native microflora. Is there any research that backs up either of these beliefs?
Yeah, this is a hypothesis that has been, well, I guess has been addressed. Let me try to remember if anybody is actually, some of the studies, some of the lists of studies actually tried to address that particular issue, and some people actually compare. For example, there are some researchers that put side by side the two types of conventional versus organic with the same, and trying to find whether there's a difference in indicator of pathogenic organisms. And I think that's, yeah, I guess I know people have addressed this issue, but I don't think we have conclusive evidence to actually say, okay, yeah, because of the flora existing in organic soils, they will be much better. The problem is with this kind of study, there are many confounding factors that oftentimes, this is something we attempted ourselves here in collaboration we have with Cindy Tong and Mike Sadowski in Soils and Horticulture, and it was fairly inconclusive. We didn't see much of a difference of survival of E. coli 157 in organic soil versus
but the data wasn't as extensive, and we're still working whether we're going to be able to publish it or not. So it's been addressed, but I don't think we have a good answer for that. But the hypothesis is there. I think it makes sense a lot. But no, I think we don't really have a conclusive.
Okay.
Yeah.
There are two questions about the risks if we eat large quantities of phages. Do you have any idea of what the risk to human consumption of them is?
Most people agree that phages are fairly safe for humans. The phages, we're already eating phages as we speak, because phages are all over the place. Almost every bite that you take from a fresh fruits and vegetable, you're going to be eating phage particles that they are not specific against pathogens. Could be specific for many of the bacteria. There is plenty of research on the toxicity that was done many years ago, and actually phages were used in the former Soviet Union instead of antibiotics to treat all sorts of infections, and most people agree. The evidence that there is not a single evidence that they could be toxic for people. But I shouldn't say that. It doesn't seem that there isn't much of evidence. One of the reasons why we tend to be confident that that would be the case is because phages tend to be extremely specific. And even the concern that some of those phages may affect some beneficial bacteria, this concern is eased by the fact that they're extremely specific. And if you look at their data with our phages for 157, they couldn't even attack all the other E. coli strains that we tested. So it's always a concern. I don't want to completely neglect or say that they pose no risk, but the consensus is that the chances for any phage preparation to be risky, it's really not very founded, or that is not supported.
Do you have any kind of projected timeline for when bacteriophages or products may be available on the market, and how expensive approximately they might be?
Bacteriophages. Well, it depends. Right now, with the first few phages I just mentioned is probably the increase is growing. The price, I don't know. I think that's something you really need to talk to those companies. Because the way they work is they work very individually with each customer. Since I'm in academia, I haven't really gone to the point of buying any of those, because, as I said, when we attempted to have any testing of those phages, they were asking us an arm and a leg to be able to use their phages, and we decided, well, we're just going to use our own phages. When they're going to become reality, I think it's a little bit we're in a stage in which they first have to show they're effective. I guess, for example, the listeria-phages, once we start seeing that they are indeed contributing some way or shape, then I think there's going to be slow. I don't know if the agriphage actually, what has been this actual effectiveness to control any of the plant pathogens. And for human use, because this is just phages that I'm proposing to use for application in foods, but there are researchers that are actually proposing to use phages directly for human consumption. And like I said, this is an old story. More than 100 years ago, people were doing it already. So I don't know. Unfortunately, I don't predict. It could be anywhere. We could go any way from either a very extensive use in the next 20 years, or that it's just one of those potential interventions that will just be very interesting at the research level, but they never really materialize to application.
Okay. We had a general question about whether you know of any good websites or documents that outline simple cleaning and sanitizing practices that producers can follow.
Mm. Yeah, not from the top of my head. The cleaning and sanitizing is one of those topics that there are tons of material, especially from extension agents that work directly with producers. I'm sure there's plenty of materials very well understood. I can give you a recommendation for a couple of textbooks if that's something that you interest. But no, I cannot think of a single website that say, oh yeah, just go to this one and that's the right one. I think it would take to search depending on the application of the particular application of interest.
Okay.
But yeah, this is a topic that it has tons of literature available out there on the web. Maybe some of them could be from local agencies too, not only extension but the government, also FDA, USDA have a lot of materials along those lines.
I know the FDA publishes a guide. We had a question from someone by email who wanted to know why heavy metals is listed as a negative aspect of organic foods. In other words, why?
Good question, and I think in here I'm probably going to send just that I took that references from a review paper that listed all the different potential safety issues, and I remember I want to include it because that particular reference actually talked about it, but that's an area that I don't recall from the top of my head what is the issue, but I think that's an issue that's certainly something that is being brought up. That's a good point. Why is that? I think again I don't have a good answer for you.
Okay, I will try to remember after the presentation to post the FDA guidelines on produce sanitation, as well as someone just commented that regarding the chlorine question that we talked about earlier, there are new updated guidelines available in the National Organic Program Handbook online about sanitation. So
okay.
I'll try to post that to this the top page.
Yeah, that would be great.
61477 at some point in the coming day. Let's see, I think we have time for one more question. Let me just go back a little bit and make sure we've gotten as many as possible. Yeah, we had a question about basically, let's see, what is wrong with chlorine, bleach, or hydrogen peroxide? I think there were a couple of questions related to that, so if you could just elaborate on that a little bit.
What is wrong, I guess, we're talking about organic foods, and what is wrong is that the principle of organic food production is to minimize artificial inputs. So there's nothing wrong as we speak for its use for sanitizing and its effectiveness. But I think that because of the environmental reasons and because of the chlorine potential effect on the environment, I think that's what the reason why it's driving this interest. But I think in terms of sanitizing, they're continuing to work. They're effective. So it depends for what purpose. And as long as we don't have anything else alternative, I think they should be continued to be used. I guess the concern is from the point of view of safety alone is that the restrictions for organic food production, whether that could potentially lead to contamination if those sanitizers are not used. But
right, in the wastewater.
Yep.
Well, we're running out of time, but I'd like to thank you all for your questions. And as I mentioned before, if you have additional questions, you can use the Ask an Expert system at extension.org/ask. This webinar was recorded and will be posted on the eOrganic website at the link on your screen. And you can also find all of our other recorded and upcoming webinars. We have one coming up next week with Helen Athow about reduced tillage in organic vegetable production. I'd like to thank you so much, Francisco, for joining us today, and thank you all for joining us.
Thank you, Alice. Thank you for inviting me. I'm happy to be part of the seminar series.
It was a pleasure. Okay.
Thank you very much.
Thank you.
Bye.
Bye.